Today we are going to learn about how to use the formula effectively in problem solving. Let's have a look at this example. It says, calculate the height of an equilateral triangle which has the same area as a circle. This is the circle with a circumference of 10 centimeters. Give your answer correct to 3 significant figures. So I'm going to underline. So I have the circumference of the circle, is 10 centimeters, and you need to find the height. Okay, and the triangle is an equilateral triangle. And this is very important as well, because we can get something out of it. It means we know more than what the problem says. So the problem says the circumference is 10 centimeters. Through this, we can get something out definitely. And the fact that the triangle is an equilateral triangle, we need to look back at the features of equilateral triangles, the degrees or the sides, right? And see what we can do with them. Right, so give your answer correct to 3 significant figures. Now, circumference is 10 centimeters. And the area of this triangle is the same as the area of the circle, which means I can, through knowing the circumference, I can get the radius out of it. See here, I have rearranged the formula. C for circumference equals 2 pi r. So r is c divided by 2 pi. I skipped a step here, so you need to divide by 2 pi both sides to get rid of 2 pi. And then I put the r on the left-hand side. And I substitute 10 over 2 times 3.14. And so the answer is going to be, so 10, 1.59, 1.59 to 3 significant figure. The answer of the r, the radius, Now, so is this one here. Now, why do I need the r? Because I need the area actually, because the question says the circle and the triangle have both the same area. So by finding out the area of the circle, I find out the area of the triangle. So now I'm going to substitute to this formula here. Let's put this as step number 1, step number 2. And formula of the circle is I equals pi r squared. And then it's going to be 3.14 times r squared is 1.59 to the power of 2. And using both mass, we need to do the power first. So 1.59 to the power of 2 is going to be 2.5281 times 3.14, and the answer is going to be 7.93. Okay, so this is the answer of the area, which means, there we go, rounded to 7.94 to 3 significant figures is 7.938, okay, to 3 significant figure. Now, so that means this is the area, centimeter squared. If you want to write down the measuring unit at this stage, it's still great. So here, what I've written down here means area of the triangle, this is the sine of the triangle, equals the area of the circle, equals 7.94 centimeters squared. So we know now the area of the triangle, so we need to know the area, the length of the height. Now, we know that the length of the height, the height is the perpendicular bisector of a equilateral triangle, which means it divides the base into 2 equal parts, and the angle here obviously is a height, so it's going to be 90 degrees. Now, we know the area, so let's write down the formula for the area of the triangle. So it is going to be height times b. I'm going to call it b capital, all the base. From here, you see the arrow, from here to here, it is the area of the base, divided by 2 equals 7.94. So, but from the other side, so b the whole b, is the same as 2 small b. So I've called with a b, small b, both parts of the base which the height had divided the base into b and b. So big B, it is equals 2 little, so b and b, 2 b's. So what I've done here, I have substituted into the whole base, I substituted 2b. So area equals h 2b over 2 equals 7.94. So h times b equals 7.94. So h times this little b here, this side from here to here, it is going to be 7.94. Now, why am I using just this triangle here? Because the height divides the angle into two equal angles, so 30 degrees each, and this angle is 60 degrees because it's an angle, the corner of a triangle, equilateral triangle. So this is 60 and this is 30. This is the height, this is the b. So tangent 30, it is the equals the opposite over the adjacent. So it is b over the height, like this. And you know that tangent 30 is square root of 3 over 3. So b, I have rearranged here. So b, it is going to be square root of 3 times h over 3. So if you multiply both sides by 3h here, this is what we get. So what I've done then, I have substituted into the area A, the big A here, because h times b, we said is 7.94. So h times all this one, so it's another substitution here, equals 7.94. So h times h makes h to the power of 2 equals 3 times 7.94 divided by square root of 3. So I have multiplied by 3 both sides to get rid of the 3. And then I have divided by square root of 3. So it's a step here that I have skipped. But you can do all the steps one by one. And so this is the stage where I'm at. H to the power of 2 equals 3 times 7.94 divided by square root of 3. Now, how do we get rid of the power? To get rid of the power, we use again the opposite operation, which is the square root. So the power of 2, okay, or square, we use the square root. So the square root of h to the power of 2 equals square root of the other side. Both sides of the equation should be in the square root. And so h, it is going to be the square root of all these, to the multiplication first, and then the square root of 3 before you do the big square root. So the answer of the square root is 13.77. And so the final answer is h equals 3.71 centimeter. 3.71 centimeter. Now, if you have a situation like this in an equation, not a problem solving, not a wordy problem solving, then the answer would be plus minus. Okay, but here the only value of h that we will use is the positive value, not the minus 3.71, because the answer won't make sense, because it's a length, and negative lengths, don't make sense. So this is the final answer. So stop the video and have a look back at how I worked this out, how I expressed the h, the base as a subject of, how I made b the subject, to be able to find the h, and how I've substituted here. So it does require sometimes a bit of time to understand, but I'm sure you're going to do it. Have a lovely day, and thank you for watching Mathssteps. Bye-bye.